I recently found myself in a tense dispute with a debt collector over some canceled bank fees. To build my defense, I fed the facts into an AI, hoping to generate a solid legal argument. The response it gave me was legally compelling, aggressively structured, and entirely flawless. But underneath that heavy, authoritative weight, it was hollow. When the bank's response arrived, the phrasing was uncanny. It mirrored my own defense, the same detached, flawless legal prose. We weren't just arguing against a corporation. We were watching two models collide in a vacuum of artificial certainty. In both outputs, wrong and right looked stylistically identical on the page. As humans reading the text, we had absolutely no linguistic signal to tell us which was which. Think about how a human junior analyst works. If they are unsure about a complex task, they hesitate, they ask questions, they flag their uncertainty. We naturally assume that confidence correlates with competence. Psychologists call this calibration. In human interactions, a confident tone usually means someone actually knows the answer. Large language models are poorly calibrated. They carry the precise linguistic signature of knowledge, the tone, the structure, the fluency, without any factual foundation to back it up. This creates the plausibility trap. We deploy systems whose tone demands our trust, while masking a total absence of understanding. To see why this happens, we have to look at how these systems actually work. An LLM does not retrieve facts from a database, and it does not reason its way toward the truth. It predicts the most statistically plausible next token based on patterns compressed from its training data. Text breaks apart into abstract numerical tokens, passing through a statistical probability filter that selects the most mathematically likely next shape, ignoring factual anchors. The system's objective function rewards minimizing prediction error, stripping away ties to reality in favor of statistical plausibility. AI researchers refer to this as epistemic indifference. The model isn't trying to be accurate and accidentally hallucinating. It does not compute truth or falsehood as variables. Garrett Phil Bauman's original article on Medium provides the full philosophical breakdown of this indifference. The AI prioritizes the statistical shape of a sentence over the facts it contains. In this architecture, certainty is not a signal of truth, it is a stylistic choice. This is a bust of the philosopher Plato. His classical definition of knowledge still anchors epistemology today. Knowledge is justified, true belief. For centuries, that definition held up. Then, in 1963, a short paper introduced the Gettier problem. It proved that a belief can be both justified and true purely by coincidence, without actually being knowledge. This describes our language models. An AI can produce outputs that happen to be true through a statistical process that looks like justification, but the connection is entirely incidental. This chart compares accuracy against confidence. The accuracy line fluctuates wildly, while the confidence line remains flat at 100%, whether citing verified data or inventing confabulations. The model does not know what it doesn't know, lacking any internal mechanism to represent doubt. An LLM's output is not knowledge. It is a highly convincing mathematical approximation of knowledge's surface. Relying on aggregate accuracy metrics to judge AI readiness is a liability for any organization. Errors are not randomly distributed. They cluster heavily in domains the model is least equipped to handle, like niche math or legal edge cases, even as reported confidence remains universally high. It answers obscure regulatory questions with the same unyielding fluency as standard contract clauses. Averages mask the true danger, the quiet failures where the AI's confidence and competence completely decouple. Because the architecture will not naturally hesitate, you must force it to break its stylistic fluency before it starts writing. This mockup shows a practical fix. By demanding a numerical confidence percentage first, the response begins with a bold 42% before launching into its standard text paragraph. This works because it forces the statistical engine to predict a probability token before it falls into the stylistic rhythm of an authoritative tone. You can dive deeper into the mechanics of epistemic indifference by reading the full article linked below. If the model doesn't actually know what it knows, what happens when you give it even more data to work with? The answer is far less obvious than the marketing suggests.